Hello. Hi guys, good morning. Welcome back to a new video. Ki halchal. I hope you guys are doing good. In this, we're gonna see a problem. Length of longest Fibonacci sequence. Again, I was recording, then I realized my audio was literally down. Let's see. So it simply says that a sequence of numbers is called Fibonacci if the length of them is 3, and also this condition follows. What is this condition? Two consecutive number, next number is addition of that, which means 1 2, next number is addition of these two, which is 3, next number is addition of these two, which is 5, next is addition of these two, which is 8. So this is a Fibonacci sequence. You are given an strictly increasing array ARR of positive integers, which is this one, and you are forming a sequence, but you have to return the length of the longest Fibonacci like sequence. And again, what we saw is Fibonacci like is this pattern. We have to return that pattern, but again, the length of the longest. I have to kind of maximize the length. Again, they have mentioned what a sequence is. Sequence is, some set of ordered integers which are taken from this array ARR. Now, obviously, at any point in time, I always refer that if it's a contest, make sure that you look at the constraints. Constraint says n is 1000. Obviously, with that in mind, I can try either O of n square or n square log n at max. I cannot try n cube or anything exponential. Okay, that's one thing in mind. But obviously, it's an interview. In an interview, you will not have any constraints in mind. Then let's start off at any random index, which means that, okay, I will try and go on to any random index I. Now, with that random index in mind, my primary aim here is that ending at this index I, what is the length of the longest sequence which I can get? And again, whenever I refer now sequence, I mean a Fibonacci like sequence. So I realize, okay, ending at index 5, give me the length of the longest sequence. But 5, which means that technically by human mind, I should be able to figure out what actually the sequence can be. But with this 5, can I figure out? No, because obviously it will depend upon what the previous element is. If the previous element is 3, now again I'm saying, just imagine if the previous element is 3. If it is, then 3, obviously I will have 5 minus 3, which is 2. So this will be 2. 5 minus 3, which is 2. Then because of these two, it will be previous will be 1. Because of these two, previous will be 0. But again, obviously 0 is not there. So I realize that, oh, I itself is not sufficient. I need to know something as well, which is previously, and with that previous one, I will be able to figure out the entire sequence altogether. Now, why I said the previous one is important? Because if my I would have been 5, and if the previous one would have been 4, then what could have been the case? Obviously, 5 minus 4 is 1. I would have taken 1. And thus you saw that the length entirely changed just because of the previous one. So earlier I went on to mid location and I was trying, okay, what is the maximum length I can get so far? But then I realized, okay, only index I is not sufficient. I would need something j as well. So I realized, okay, I wanted at index I, ending at index I, wanted the maximum length of the sequence, or I should say Fibonacci sequence. But then I realized, okay, it should be paired up with some j, because that is something will be different, because a specific ji will have a different length. And this is, I can store as maximum length of subsequence, ending at index I, but also the previous one was j, because that will differ. If the j is here, then the length is 4. If the j is here, the length is 3. Okay. Now, so one thing we realized that, okay, this feels a bit comfortable now. But the catch here is, because I have already used I and j, so it has already passed O of n square. Again, obviously, if I'm trying for all ij pairs, it will go to O of n square, which means that I don't have much liberty now, which ultimately means that if I try for some ij pair, I want to get the length. Technically, that's the aim. I want to get the length ending at that ij pair. Ij pair, I want to get the length. For that, I realized I will easily be able to figure out this index. Let's name it as previous index, right? Right? This previous index. But for that previous index, I have to find the previous value. What is this previous value? This previous value will be ARR of I minus ARR of j. So previous value I will have. I can maintain a hash map, because the problem said that all it is a strictly increasing, which means I will never have any repeating element. With that in mind, because I will never have a repeating element, thus I can maintain a hash map. Hash map saying for any specific value, what is its corresponding index. because there will be only one values for one index, so it is easy for me to maintain a hash map. With that hash map in mind, I can say, okay, whenever I am trying to get to any length whatsoever, ij, which means ending at index I, but backing index is j, which means the previous index is j. I will simply ask ending at index j with the previous value as previous value, and the previous index will be this one. So I can ask ending at index j and then the previous index, whatever was the length, just add a plus 1 to increase now the length for ij. So I'll just simply add a plus 1. What is actually I'm doing? I'm simply using the previous state. What is this? It is nothing but a dp. So that is how we realize that I can leverage dp by saying my dp of ij will be nothing but 1 plus dp of j comma previous index. And I easily saw that because my time can go to O of n square, that is completely fine. And also j, it is same as what we have. How to find this previous index? This previous index, is very simple, which is just referring the previous value. So with the help of previous value, I can figure out the previous index by simply maintaining a hash map. I can maintain a index map, a hash map, and then I will populate that index map hash map with all the values, which means for value, let's say for value 1, index 0, for value 2, index 1, and so on and so forth. And with that, I will pass in the previous value, which I can easily compute. As I told you, previous value can easily be computed by simple ARR of I minus ARR of j. With that, it will give me the previous index, and that previous index I can put up here. And that's how simply you can solve it. No other logic at all. And because you are simply memorizing at every step, that's completely fine. Cool. Let's see how we will write the code for it. Again, if we want to just show that how we will write the code, firstly, we know 1, 2, 3, 4, 5, 6, 7. I will initialize my DP, obviously. In the very beginning itself, for any ij pair, it is valid. Any ij pair is valid. So any ij pair will be initialized with the value of 2. That's one thing. So my dp itself will be initialized to 2. So I can say that I will initialize my dp with a value of 2. Then obviously I will go on to all the i's. So I can simply write it as for int I equal to 0, I is less than n, and then I plus plus. And obviously I saw that my j will be something previous, because again it is up till this point whatever is the answer. So I will try for the previous I. So previous j. So I will say j equal to 0, j is less than n, and then j plus plus. Now, obviously, there's one thing I told you that I need to know for any specific value what is its corresponding index. For that, either you can run a for loop previously, just do a pre-computation, or what we can do, we can put up here also that index map will say that for this value, which is ARR of I, this is the corresponding index I. Right? This is how I can do it. Although if you want, you can just do a pre-computation as well. Just run a one for loop and build this hash map. If not, then you are good. Okay, now comes the fun part, which means now I can utilize my dp. How I will do that? I will simply say that dp of ij will be nothing but what? Obviously 1 plus dp of j comma simple, your previous index, or I should say index map of previous value. Index map of previous value. But for that previous value, if it is bracket, yeah, for the previous value, I need to find the previous value. So I'll just say that my previous value will be nothing but ARR of I minus ARR of j, right? But obviously, there's a small catch that this previous value should be there in my index map, and also its index should be lesser than j. So I will have to have a condition here that, just change the color. I'll have a condition that obviously my index map should contain this previous value, because obviously then only I will be able to find its count, else it will give me a value 0, which is incorrect, right? So I'll just check that my previous value should be there, and also at the same point I'll check my index map previous value, which means the actual index. This is the actual index of the previous value. It should be less than my j. In that case only, I should make sure that I update my dp. And obviously I know that as I'm updating my dp, I want to maximize the length, and this is giving the maximum length, saying ending at index I with the previous index as j, what is the maximum length so far. So at this step itself, I can say that, just simply maximize the length. just utilizing the same space. So I'll say that maximum length and dp of this value, which is I comma j. And ultimately, I can simply return this maximum length as an answer. So in the very end, I can return that maximum length. Make sure that this maximum length obviously should be more than 2, which is starting from 3 itself. That's the question demand, not our demand. So I'll just say if it is more than 2, then obviously return the maximum length. And if not, then return 0, because that's what I have to return. And that is how simply you can do it. Again, people tend to go towards nahi Aryan, I have to do top down approach. No, I have already told you in many practice. Again, if you don't know DP, so simply go on to the DP section here. If I come down DP and try for simple problems of DP, you will realize that many problems are there which are much simpler as a bottom approach rather than top down. Again, I will not make that specific box and stuff. That's literally bullshit for this kind of problems. But again, if you want to optimize, or optimize this state and all that, then you might end up thinking about that. But for that also, I have told you many tricks which does not require this, right? So never make boxes and stuff. It wastes time. It is not something which you can make in an interview. And also that is not intuitive. Intuitive is just go on to a middle state and then figure out the actual state and the recursive relationship, or any relationship which you can figure out from the current state with the previous state, and then you utilize that specific previous state to get to a current state. And with that in mind, you will get your answer. Cool. Let's see the code. It's exactly same as what I showed you, that firstly I will initialize my DP with a value of 2, because obviously any IJ pair will have a minimum length of 2. So like any Fibonacci sequence will have a length of 2. Then I have exact same code as what I showed you. I will not explain right now, but exactly same code. Because of this, time will be O of n square, and that is perfectly okay, because I saw that okay, O of n square will work. Space, because I used a DP, it will be O of n square, but I also used a hash map, which is an index map. Thus, the space will be O of n. Now, did you see something very clever in this? The array is strictly increasing. You have all distinct elements, and then you are finding two ij things. Did you see something which is familiar? Yes, because if you would have solved two-sum problem, right, you would have seen this is exactly same kind of two-sum thing. With that two-sum in mind, right? Again, two-sum in mind, the two-sum problem in mind, let's try to see that how I can utilize my two-sum and find out my answer. So the two-sum simply says that if you want to find two numbers, if you want to find these two numbers who sum up to a specific index or specific value, then you don't have to go on to all the elements and then take a hash map for the third element. No, what you can simply do is that, because this is strictly increasing, which we have already seen in this problem. If you don't know what two-pointer approach is to approach getting a two-sum, make sure that you watch this two-sum video. Just simply click on it, and you can simply watch this two-sum video. Now in that, it will simply say that okay, I will go on to all the indexes one by one, same way as I was doing previously. So let's say this is my current index, right? Current index. Again, which means that I am at this point in time. Now, if you remember in the previous step, this current was replaced with I, then I was looking for any previous j. With that previous j, I was looking and using a hash map to find my previous index. But now I will say, okay, I have to find j and previous index. That's what I want to find, right? Okay, for that I have to find, which means that it will be in this range. So in this range, I will have some j and some previous index. So I will start from here. Okay, start from here. Extreme points, right? Start from extreme points. So I will say this is my previous index and this is my j. And then I can simply use my approach of two pointers just so that it sum up to 5. So firstly, here in this case, as you can see, these two are having the sum which is equal to 5. In that case, yes. Make sure that you say that dp of ij will be nothing but dp of j and your previous index plus 1. As simple as that. And making sure that same logic, maximize the length. So I will say maximum length will be maximum length comma this specific value, which is dp of ij. Exact same code again, exact same code. The only catch here is now both should move forward. So this is previous index and this is my j. Okay, in that case you realize, oh, both are again matching. These both some are again matching. obviously in that case, again, I'll try to update my dpij value and I'll move forward. So this is, I showed you happy case when both are matching. But let's take a non-happy case, which means not both are matching. Not both are matching. What will be that specific case? Okay, let's try again, because this array itself is actually, very symmetric, so there's a lot of happy cases here. Let's take another example, which is 1 3 7 1 3 7 11 12 14 and 18, right? Let's now take this one. So with that one in mind, okay, let's say my current is here. So obviously my previous index is here, previous idx. Again, in the code you will see I have replaced it with left and right. So it is left, it is right. This is how I've replaced, just for that being symmetric with what we have in twosome. So now that with that in mind, I realize, okay, now this is the scene that I have these two numbers and they sum up to 18. This is what I want. But right now they sum up to 15. They sum up to 15, which is less than 18. So obviously what should move? Left should move because it is less. It is less. So left should move. Now it is a number 17, which is again less than 18. No worries. So again my left should move. Now it is 17 plus, 14 plus 7, which is 21. It is more. Oh, in that case, right should move. Right should move. Now again, it is 19. Again higher than 18. No worries. Again, right should move. And now, oh, now it is 18 matching. Oh, yes, great, awesome. In that case, simply I'll say that dp of, current and with the value previous as right will be nothing but 1 plus dp of right and then left. And with that, because by default you will see that every ij pair value will be having a length of 2, so it will be 1 plus 2, which is 3, and thus I will get a value of 3 easily, which is these as the ones. Cool. Again, this is exactly same as what we saw in two-pointer approach by getting a twosome. Again, if you want, you can have threesome as well. Again, like not you having threesome, but threesome problem as well. So if I come down, I should be having threesome. Okay, where is threesome? Okay, it should be in two pointers. And if I go to medium category, okay, I'll add a threesome here. I'm not sure why threesome is not there. Okay, I'll add threesome here, but it will be there. It is again. It also involves the same logic. Now, let's see the code. It's exactly same as what we saw. That firstly initialize the DP itself. Then I will move on to the current, starting from index 2 by index 2, because obviously I need previous two indexes as well, which is I and j, or I should rather say previous index and j, which I have represented by left and right. With that in mind, I will simply say while left is less than equal to right, simply get the sum which you wanted. It's a demand. And then if the sum, this is the current sum which I have of these 2 points left and right. If this is equal, then obviously what we did, and then moving both the pointers. If left is higher, if the sum, if both of these which adds a sum, if the sum is higher than the current number which I have, then obviously move back this right pointer, right? This right pointer. If it is less, then move this front pointer, this front pointer. And with that, I will be able to, try for all the actual indexes of left and right, which will give me a sum of whatever I have at current index, which is index I in our case. And ultimately same logic, that if the maximum length is more than 2, simply return the maximum length, else return the value of 0. And with that, you have eliminated just the case of using a hash map. And with that, you are using still O of n square time, but now O of n square space only, which is because of TB. Cool. I hope you guys liked it. Please make sure that we hit the like target of 100 likes. Bye bye. Take care. And I'll add it. The problems. But yeah, the simple twosome is more than enough for you to solve it. Bye bye.